All right, now this will be a recording for your practice test, getting you ready for test 4, chapter 5. Now, I know some of you made it a point to bring it to my attention that of this note, that to complete all the odd problems as a practice test, if needed, complete all even problems as a second practice test. Now, that, as you can see, is from Professor Allen. She's the one who made that note. Now, I personally think that the more practice you do, the less opportunity you have for trickery. Or, hey, I don't remember seeing that, right? I mean, it's easy for us to give ourselves reasoning for why we're unsuccessful. So I don't ever believe in just doing half of anything. I do everything completely. Um, because once I figure I could do it enough and I could do it in my sleep, I could basically go through the test with no problem, with no issues, with no feeling of anxiety. I mean, I know some of this, we can't get away from that. And it's just a shame that sometimes we're plagued by our unfortunate demise, like our own mind gets in our way, basically, our anxiety and all things. So I say do them all, is what I'm basically saying. Now, I will now guide you through some problems because I'm not going to do them all, but you can do as much as you want or as little as you want in order to be successful. This is a homework problem. This is a homework, um, homework grade. So you determine whether or not you want to get the homework grade. All right, that's how it works. So if you do 50% of it, then so be it. Then you get 50% for it. That's how I look at it. But now let's go ahead and go over question number 4. Okay. Now question number 4 says the parent function of the exponential function and the transformation technique to graph it is such as indicated. What does the transformations mean, basically? Okay. So when we're looking at this, because we're looking at e raised to some power, we know that some power is moving to the left 4 units. It's making the exponential function move to the left 4 units because it's positive. And I told you how that works. And it's also moving 7 units down. Now there's no component here, there's no value here, and there's no value here. So there's no reflection or shrinking or stretching of the function. All right. So when we're looking at this, then this is what I just indicated is now identified right here. So it's 7 units down, 4 units to the left. Now the graph then being that it is an exponential function, and exponential functions, what we do is we take a critical component value, which that critical component is 0, 1, and we go ahead and translate that in accordance to what we just said. So 4 units, 1, 2, 3, 4, 7 units down, 1, 2, 3, 4, 5, 6, 7 units down, puts our new critical point here. So that makes our new horizontal asymptote, because this does have horizontal asymptote at the value of 6, right? 1, 2, 3, 4, 5, 6, 7. Hold on, that not that point, but this horizontal point moves it down to here. Okay, excuse me. So now we have our horizontal asymptote here, where we have y equals -7. Okay, so we have that. It's moved down. Okay, so now we're looking at a value system that looks like this. All right, it's doing something of that magnitude. So we're now looking for problems that do that, and this one, all right, could potentially be it. All right, because that one does look good. This one moved up, this one moved up, and this one moved down, but over to the right and not to the left. So it has to be this one as our answer. Okay, and that it is. Now the domain of all exponential functions is from negative infinity to positive infinity. Now the range is wherever the value of our horizontal asymptote is going to positive infinity, as long as it has not been reflected, right? So it's going to be from -7 to positive infinity. Now, the equation of the horizontal asymptote, I just gave it, it's right there. It's always going to be the same value that you have for your, your value of your x right here. All right, and that is number 4. Let's take a look at number 5. Now we looked at exponential. Let's take a look at logarithmic function. So this one now has the properties. Now this function, when we graph it, looks like this. Okay, now it's the opposite. Excuse me, logarithmic function. It's the inverse. All right, disregard that. All right, the logarithmic function looks like this. Okay, now this one has been reflected over the x-axis. All right, I said x-axis. Let's go negative. Take that back. It's going to be the y-axis. All right, it's reflecting over the y-axis, so it looks like this, but it's also 6 units down. So here, this critical component right here is moving 6 units down. So, well, we go ahead and do that. 1, 2, 3, 4, 5, 6 units down. It's going to be reflected over the y-axis, so it's going to look like something like that. Now, the thing is that the vertical asymptote hadn't changed. All right, it'll just look like this. All right, that's what it'll basically look like. So this has been reflected over the y-axis and used and moved 6 units down. So 6 units down and then reflected over the y-axis. So we would go ahead and graph those parts in there, and it'll look like this. Is what I have basically written here. Okay. So we want to make sure we pay attention to how to do that. Now, the domain of a logarithmic function is restricted. The range is not. This one's going to be negative infinity, positive infinity for the range. All right. Now, the domain, however, is restricted based off of the fact that it has a vertical asymptote at the where x equals 0. So it's going to be from negative infinity all the way up to that critical component. So that's what our domain is going to be. It's from negative infinity to 0. And now the equation is, like I said, x equals 0. All right. And then we have our graph already drawn. So those things are the properties of graphing with transformations on both the exponential functions and the logarithmic functions. You'll be expected to do that on your test. Now I'm going to bounce over to a question here that is going to be also a question you're going to have that I want to go over. All right, write the following logarithmic equation in the equivalent exponential form. So when we're talking about that, remember that since it's log, we take the base of the log and we move it, and I put the base of the log like this. So let's say log base 7 of the 1 over 343, and then we have it with the -3 equal to -3. We move the 7 over and make it become the base of the log. And then we're going to set that equal to what we have, all right, here. And there becomes then our answer. All right. Now, could you put it as 1 over 343 equals 7 to the -3rd? Yes, you could. But here it is, what we're expected to have. Apologize. Let me sorry. Okay, now let's take a look at question number 8. Now, number 8, okay, it asks us to find the exact value of the following logarithmic expression. Now, here's the thing. When you're talking about 64, all right, it says log base 8 of 1 over 64. We recall that it's 1 over 64. We can go ahead and make it become this way. log base 8 of 64 to the negative first. Now these don't match. And remember what I told you about the property we're looking for is where they match. And this comes from one of your lessons. And if you don't know what I'm talking about, then you need to watch the lesson. All right. And since we want it to match, we can go ahead and make it become 8. But then what does 64 do to become 8? All right. That's ultimately the question. Well, if we go ahead and take 8 to the second power, that is 64, and still we have the value that is there still. Well, wait a second, there's a -1, so this becomes -2. So, I mean, otherwise, I don't feel like doing it, but you take the -1 and you multiply it against the 2, and it becomes -2. All right? So then we get that, so our answer then becomes whatever is in this position, which is -2, and that is our answer we're looking for here. All right, now let's take a look at number 9. Now, number 9 says we have the log of 4, log base 4 of 1 over the radical of this. Okay? Now, all we got to do is go ahead and, since this is already a 4 and this is a 4, we need to go ahead and reposition things so that way it's in the form of where it's the same, and then all we do is take the value of the exponential power. Since it's the index, we can go ahead and change that to 4 to the negative, or not negative, but it will be in a second, but it's 4 to the 1/3. All right, so we change this to 4 to the 1/3. That's what we'll change that to. Now what we'll do is bring this up to the top, so that way it becomes a -1/3. So that way we can get it to be where these match. So this will be what we come up with so far. So the answer is then just -1/3. And that's all we have for our answer. Now for number 11. Number 11 says find the exact value of this log again. So we have log of 1/3, log base 1/3 of then 729. Now the thing about 729, I would imagine it has to do something with 1/3. Okay. Now all I got to do is try to think, well, wait a second, what about 3 raised to some power? Is it going to give me 729? So if we go ahead and raise 3, and I'm doing it on my calculator, all right? We raise 3 to, let's say, the I don't know, the 3 to the 7th power. That gives us way too high. So we're going to back that down then. I mean, because we don't know, we're going to go ahead and do like 3 to the 5th power and see what happens there. Now, it's still not giving us the right number. So I guess we're in between them, 3 to the 6th power. And there it is. Okay. I know it's hard for you to see my screen. It's hard with the colors and stuff, but I'll just go ahead and show you what I did. Well, I was taking guesses, all right, and I was going ahead and putting in different values for 3 to the 7th, 3 to the 5th, and 3 to the 6th, and see finally that it equals 729. Now, the problem is, though, is that this is 1/3 and not 3. So what we do is go ahead and do the following. Watch. Okay, so we have this, and then we have 3 to the 6th power. I want to get this to be 1/3 or a fraction thereof. So what I can do is go ahead and reciprocate this, all right, and then make that a -6. So what we'll do is go ahead and do this. One, base. All right, so what we have is now we're going to take and reciprocate 3 over 1 and make it 1/3. And then when we do that, we make the 6 become a negative. And now these match, then I'm left with just -6 as my answer here. All right, and that's the answer that we're looking for here. All right, so that's how you proceed to do those kinds of problems. Now let's take a look at this question here. Now, this comes from section 5.2b, Logarithmic Functions, Part 2. All right, graphing logarithmic functions, as this came from section 5.2a, Logarithmic Functions, Part 1. So this is question number 20, as this was question number 9 from those lessons, okay? Now it says determine the domain of each of the following functions. Now, this is h of x. So it says log base 9 of, and then it says negative 2x minus 4. Now, if we recall, logarithmic functions has domain restriction. So all you do is set the contents of the logarithmic function equal to 0 or greater than or equal to 0. All right. Now, when you go ahead and actually it can't equal 0. Remember that? So we're going to say greater than 0. So then in that case, all right, we go ahead and say, well, it's not equal to it, so it can't be, because you can't take the log of a 0. That's why I had to correct myself in that. So I'm going to go ahead and set this equal to 0, and I'm going to solve for it. Well, the parentheses mean nothing, so I'm going to go ahead and throw those out. So I'm going to go ahead and move the 4 over, make it become positive, and then divide both sides by 2. And then because, all right, because this, we're going to go ahead and not set it equal to 0, but set it greater than 0. Because I divide by negative, okay, I'm going to have to switch the equality sign. And then I have this, that x is less than or equal to negative, not equal to, sorry, I keep on saying wrong words, but x is less than negative 2. We get then the interval notation of negative infinity all the way up to 2 and not inclusive. So that means the vertical asymptote is at negative 2, and we can't be equal to it. Now you do that same process for each of these. So I'll do them because they're pretty easy. 12 plus 3x, that has to be greater than 0. We go in and bring that over. So it's 3x, negative 12, divide both sides by 3. And we get x is greater than negative 4. So then in interval notation, then we have to say, well, exclusive to negative 4, but then all the way to infinity. So there's our interval notation, and here's the answer we were looking for that is indicated here. So that means that the vertical asymptote is negative 4. So x equals negative 4. Now we get the last one. Now I want you to take note, there isn't typo here, that when it says the g of x and then it says the function of h, that doesn't match. So that should be h down here. Or excuse me, that h should be g, I mean. So it's, see how it says domain of g and then it says function h? So that's a typo. That should say g. So anyway, what we do is go ahead and do the same thing we've been doing with all these. We go ahead and set that greater than 0. Now we're going to go ahead and factor this. So what two numbers multiply together to create negative 5 that add up to negative 4 would be negative 5 and plus 1. All right. And then, so what we get is two factors. So it's going to be obviously positive 5. All right. And then we go ahead. Those are two domain restrictions. So it's we're going to go ahead and get these values of that, where it's 5, and then we get negative 1. Now the thing is that for this, because this is a logarithmic function, we have to, like I said, be careful with the system. And what we end up with is that we have less than negative 1, and then we have also greater than 5. All right. Now, another way of also doing it is by looking at on a graph and seeing what it looks like. So the vertical asymptotes are at the fact of either you could put in this box negative or x equals negative 1 or x equals 5 for this box, and then the other one over here. So you guys just put both of them. It's x equals negative 1 and x equals 5. Okay, so that's how you do that problem. Now for this one, number 14. We're looking at the expansion of this. So this is natural log and if we're expanding, this is going to be split. So we're going to go ahead and split that up to be ln of x to the 13th, but the 13 has to go ahead and be brought back down. So then we have that with a plus sign, and then the 20 comes down and becomes ln with the w, and then it's going to be a minus sign 14 ln of y, and then that's our expansion, and we're done. All right, now I'll take note about this y subtraction, just because of course we're dividing. All right, pretty simple stuff there. Now we take a look at number 16. Now it says condense it. So since we're condensing this problem, we notice that there's an 18 and we have a plus log 6, 12. So now, since it's an addition, we know we're multiplying this, right? Okay, so we're going to go ahead and multiply it. We can take our calculators, just do that 18 times 12 and get 216. So we get log base 6 of 216. Now 216 is 6 to the third power. All right. So 2 to the 6th power, or excuse me, 6 to the third power is what we get there for that. So we're going to get log base 6 of 6 to the third power. That means our answer is 3. So we get our answer. All right. Now number 17. It wants us to condense it again. So this is where we have to go ahead and bring up the power. All right, so we go ahead and bring up the power. That's going to be z to the 9th, and then x to the 15th, and then they're going to multiply each other. So our answer will be log of z to the 9th, x to the 15th. And then that's our answer. Now you could put the x first. It doesn't matter, but that's how we have it. All right. Now, it's not in good habit that I leave off the parentheses. So I should be reminding you should be putting parentheses around these values. Not in this case, but in this case, absolutely. All right, now number 19. It says to rewrite the given expression using common logarithms only. Now, common logarithms is just log. So what they're trying to do is change a base formula, basically. So the change base formula says take the log of what you're taking the log of, which is the 7, and then you have the log of the base. So then it's log of 17. So that would be the answer we're looking for the top here. All right. And again, I have a bad habit of not putting in the parentheses. The system won't let you put it in without. Okay. Now, when we're looking at this, we want to go ahead and evaluate it. So we're going to take the calculator and do that. Now, all you got to do for this is take and punch it in. So we're going to take, because it wants this common log, right? So we're taking common log, and then the value is 7 divided by common log 17. All right, and now we get this value. And it says to approximate it to 4 decimal places. So then we're going to get the approximation to equal 0.6868. All right. So that's all that is. Now, in all respect to this as well, we can go ahead and also hit math up to A, and then put in 17, and then put 7, and get the same exact answer. So I just want you to be pointed out to that fact that you can, if your calculator does have the capability of running the change-based formula, then you can use it. But the setup won't be provided if you don't. So that's why you have to know the change-based formula. Now, number 20. Okay. Now, 20 has it where it says solve the following exponential equation. Now, I remember teaching you that you need to get the base to be the same in order so you can set the exponential powers as equal to each other. So what we're going to do is move the 4 up and make it negative exponential power. And then now we have at least a 4 on the same level playing field as the 2. Now we know that 4 is 2 times 2, or 2 to the second power. So we can do 2 to the negative 2 is equal to, and then we can go ahead and get this. And because these are the same now, we set the exponential powers equal to each other. We get negative 2 equals 5n minus 8. And because of that, we can go ahead and combine like terms and then divide and get our answer. So when we do, we combine it, we go ahead and add 8 to negative 2, we get 6. And then our answer will be n is equal to 6/5. Okay. That's consistent with the teachings I gave to you before. Now we can do the same thing with this one. All right. For 22. All right. We can say, well, no, I know that 81 is 3 to the 4th power. And I know 27 is 3 to the 3rd power. And because of that, we could simply then just reduce it down, or just set the exponential powers equal to each other. And then say now that we have that, x is equal to 3/4. All right. And then that's our answer. The approach I'm giving you, very systematic. And it's very consistent with what I've taught you in my lessons. Now it's to solve the following exponential power, or excuse me, exponential equation using logarithms to express it. So we're going to go ahead and write that down. Now, we're going to go ahead and get this by itself. So we're going to go ahead and do e, and then 4u minus 8. And then we're going to add that to both sides. All right. Now we're going to go ahead and do ln to both sides. Now, when we do ln to both sides, this wipes this out, leaving us with 4u minus 8 equals ln of 348. And now we can go ahead and add 8 to both sides. And then adding 8 to both sides gives us ln of 356. And then we're going to go ahead and divide both sides by 4. Now the exact value for u is this right here, ln 356 divided by 4. So let's go ahead and make sure that we got that. Now, they went ahead and stopped it prematurely, which is appropriate. This is an ln. I made a mistake. That's not premature. That's my bad. So then this is going to be plus 8, and I made a mistake. I love making mistakes. Why did I do that? It's because I wasn't thinking about the ln at all. And that's what happens when you don't think. So I made a mistake, and you need to fix that in your notes. So don't do that. I'm glad to check the answer. I made a mistake. Okay, so now you get this. And now you can punch it in your calculator. Okay. So now we get that. We take alpha y equals fraction and do ln of 348 plus 8. And by the way, you gotta close out the parenthesis. And then divide by 4. All right. All right, so we're going to go ahead and get that value. All right. So we get the answer. Glad to go over that one. All right, now let's go ahead and do this one. Rewrite the logarithm equation, express exponential form. So we're going to move this over to here, okay? And then that's going to move the base of the log away from the component of this. So we're going to go ahead and set this equal to, and then it's going to be 2 to the 7th power. And then we can evaluate that, okay? We can actually evaluate it. So we get that, okay? And it says solve the logarithmic equation, and because that's what we're basically doing now. And so we're going to take 2 raised to the 7th power and add 7 to it. And we're going to get 135. All right. And all you do that is on your calculator. And you can't see it a little bit. But you can do it on your own calculator. All right. 30. Now it says solve the following logarithmic equation. If multiple solutions exist, enter solutions using comma separated list. Now, I see that every one of these has a log base 4 except for the last term over here. So what I'm going to do is I'm going to rewrite 2 with a base log base 4. So I'm going to take and change that to log base 4 of 4. But wait a second, we need it to be 2. So I need it to be 16. Okay, because then isn't that 4 times 4, which is 4 squared? And then they would match, and they would bring it down to 2. So this is the equivalent value of 2 for that. Now they all have logs, and because they all have logs, we want to go ahead and condense this down by division, and then we get this. And then that brings it to one singular log with the base 4. And since both of them have log base 4 and they're all singular terms of both sides, we set these components equal to each other. So these go away. So now we're left with this. 3x minus 16, or excuse me, plus 16 over negative 7x minus 9 equals 16. Now we're going to go ahead and multiply both sides by this, and then solve it. I'm going to go ahead and do that over here. So I'm going to go ahead and do negative 3x plus 16 equals, and then 7 times 16 is negative 112, and then that's x. And then I have negative, or 9 times 16 with a negative on it, and that's negative 144. All right, now I just distributed this out to both parts. Now I'm going to go ahead and bring all my like terms together. I'm going to add 112 to both sides. All right, so I bring that over to here, and that gives me positive 109. And then I'm going to go ahead and take 144, and I'm going to subtract 16 from it, and that gives me 128. All right, so I brought that over to there. Nope, it doesn't, excuse me. I just go ahead and do 144 plus 16. It's 160. All right, so I got that right. Okay, now I'm going to go ahead and divide both sides by 109. All right, so I can't do it, so I'm just going to leave it as that. And so I'm going to get that as my solution for this. Now I can go ahead and take 160 and see if it can become a a fraction that's reduced. But then I go ahead and see that it can't. So I just leave it as long. Whoops. All right, so it's the negative 160 over the 109 as I've given you. All right, so there's some steps in that, and there's a process of just eliminating, condensing and then rewriting. So there's quite a few pieces, and this, like I showed you this before. All right, and I can make mistakes with signs and stuff just like you, but I'm trying to get through so many problems, and it's getting me worn out. But you'll figure it out. Okay, let's go ahead and move on to the next question. Let's try 31. All right, log base 2 of x minus 1 plus log base 2 of x plus 3 equals, and now because I have the log base 2's, like the problem we just did, I'm going to rewrite 5. So I have to have a log base 2. So somehow I have to get it to 5. And if it's 32, then it'd be 2 to the 5th power, which equals the 5 that we're looking for. So that's why I came up with 32. Now, if you're not good at doing that, you can just do it mentally. 32, you can do 2 to the 5th power and see what it comes up to. And you can get the 32. I know it's very faint there, because every time I turn this thing on, it brightens up. All right, so I just do that. All right, that's how I test out my theories and make sure those are 2 with a 5 and everything else. Not hard to do. I mean, you're thinking about what is 2 to the 5th power to get that 5. So now that that happened, this is going to be where I multiply these together, because obviously it's plus, and I need to condense it. So it's going to be this. And since these both now have the same exact log, all right, I'm going to eliminate the logs. All right. Now we're going to go ahead and set this equal to that. And so we're going to get this. And then I'm going to go ahead and I'm going to subtract 32 from both sides. All right, and that's going to give me 35. It's negative, of course. Now, 7 times 5 is 35. That adds up to positive 2. And so the two answers that we came up with is x equals -7 and x equals 5. Now we have to make sure that with each component that we do take a look at, that it doesn't result a negative value inside the logarithm. And so when we look at it, -7 put in here, that's going to give us -7 minus 1 is -8. So this is a throwaway. We can't use that value. So this is the answer we're looking for. And that's why the answer is 5. Okay, we have to make sure it works. It's called an extraneous answer solution. It works for the process, doesn't work for the answer. All right. Let's take a look at number 32. I'm going to sharpen my pencil. All right. Now, let's see this one. It wants us to solve the following logarithmic equation again. Now, we're going to get this over to the other side. When we bring it over to the other side, it's going to become +9. +9 added to -1 is going to give us 8. Now we're going to divide both sides by -5. That gives us then ln of w equals -8/5. And now because we have ln of w and we want to solve for w, we're going to raise it up on an elevator, as I've indicated to you before. All right, we want to kill the logarithmic function by that elevator concept. And then we're going to go ahead and raise this other side and then raise e to the -8/5. All right, and then we go ahead and put that as our answer. Okay, now it will work if you put in e raised to the -8/5. It would work. All right, just do what you're comfortable with, and then punching it in your calculator. And I'm going to assume you know how to punch it in your calculator, round it to the 4 decimal places. You can get the following. $33. Says solving this. All right, since it's going ahead and adding, I'm going to multiply. So what I'm going to do is I'm going to get negative. Immediately, I'm going to go ahead and put ln -3w and then plus 39 equals, and then I have ln and then minus w plus minus 13. I'm going to go ahead and dismiss the ln's. All right, so I'm going to wipe them out because they're both the same basis. I'm going to go ahead and set these equal to each other, and I'm going to solve it. So I'm going to go ahead. I'm going to personally take and add 3 to both sides. Then I'm going to go ahead and add 13 to both sides. Adding 13, that's 5. 52 divided by 2. Okay, then that's going to give me 2. That's 26. Okay. So now I have my answer. Now I go back to my answer and determine whether or not 26 will work. Well, there's w, if it's not negative, which is not, according to the process that we've just completed, all right, and I'm double checking the work, right? It looks like the w equaling 26 doesn't work. And I can't see it right now that it's not answer, because we add 3 to both sides. That's going to give you w is 2w, and then we add 13 to both sides. And then that means that there's no solution. Okay, so this doesn't work. All right, so be careful about that. Remember, it has to work for the equation because it cannot be infringing upon the domain restriction. If it does, we throw it out. .34, we're solving this again. Now, since we're solving this for the logs, we're going to see that we're going to combine these with multiplication. And since we want there to be a log on both sides, so we can go ahead and set them equal to each other, we're going to put log 3. And then we need 3. And the only way to get 3 is if this, or 4 is if this was 81. All right, so that way they are the same. All right, now they're the same. I go ahead and set them equal to each other. And then I'm going to go ahead and bring the 81 over, make it negative. So I'm going to bring that up here because I'm falling off the page. All right, so it's going to be, I don't like the leading coefficient to be negative, so I'm going to bring everything over to the right side. So that's going to make it positive 2x minus 18x plus 81 equals 0. All right, and then what two numbers multiply together create 81 that add up to 18 is 9 times 9, but negative 9 times negative 9. All right, so we're going to have two answers of negative 9, and this is a perfect square. All right, so x equals 9. So we go ahead and double check 9, and it looks like it fits in the domain restrictions. So the answer, oops, that's not the answer we're looking for. Did I just do the wrong one? I was supposed to do, yeah, I did that one. Okay, yeah, okay. I just clicked on the wrong one. All right, so it's 9 is for number 34, and that's correct. That's how we solved it, okay? Now let's do 36. Now 36, like most of these, is a matter of just using a formula. Now it says use the formula above to determine how long it will take for the initial investment of $8,000 to grow to $32,000 or $31,200. If the account earns 8.28% interest per year compounded quarterly. So quarterly is 4 times a year. All right. So we're going to go ahead and do I'm going to put the numbers in there so I don't have to rewrite it twice. The formula and then the numbers. So it's the amount in the account is $31,200, and the initial investment is of $8,000. Now we have the interest of 8.28, so that's going to be 0.0828, and then that's going to be over 4 raised to the 4 times t power, because we don't know how long it's taking. That's what they're asking. All right. So now we go ahead and do this. We divide this into this. So we're going to take and divide both sides by that. Okay. And then, all right, let me just do that. So taking the value of 31,200, we're going to divide it by 8,000. And then we're going to get 3.9. So I'm just punching in my calculator. I'm telling you what to punch in. I'm tired of zooming in and out of this thing, and then it causes me to be blurry and stuff like that for you. I'm sorry that you can't see my calculator. I get kind of annoyed by that. I forget to resume every single time, and it's like you're looking at blurriness all the time. I apologize about that. So now what we do is take the 0.0828, divide it by 4, and then we're going to go ahead and get this. And we need this down, okay? We need to get this down. So what we do is take ln of both sides. All right. And then we're going to go ahead and move that 4 down. Now what we need to do to find for t, we need to just simply divide everything by this ln of 1.0207 times 4, okay? And do the same thing over here. So what we're going to do is take your calculators and punch in this. So I'm going to do that now. ln, you got to see it, 3.9 divided by ln 0.207, and then close parenthesis times 4. And then we get this. I'll see, it's really hard for you to see it, but I'm not zooming out, I'm sorry. Punch in your own calculator. It's going to give you 16.606. Now say after around 2 decimal places, so it's going to be 16.61 years. Okay, so this is all wiped out once you divide it, and that's why t is left alone, by the way. I'm sure you know that. So this is a matter of using your calculators. All right. I can't explain it any easier than that, but that's the way the process works. These problems are not that complicated, but you got to feel good for them, about them. Now, it's saying that we have, if 27,000 is invested in 23 years and earns 6.5% compounded annually, the accumulated amount is blank. So what they're asking you for is to punch in the into the calculator this into this equation, these values. All right, and it's compounded annually. So you're just going to go ahead and drop it into the calculator. So it's going to be let's clear everything out. 27,000, and then open parenthesis 1 plus, and then I'm going to put a fraction in there. The rate is 6.5%. We don't have a percent sign in here, so 0.065. All divided by, it says it's compounded annually. So I'm going to put a 1 in there. It won't make a difference in my evaluation system, but it's going to make it so it's set up for the next problems because it's annually. So times 23 years. So I put a 1 and then a 23. Because this, I'm going to set it up for the next time I do this. So then I get the amount of $114,922.41. All right, exactly what I just told you was what's here. Now what I do is come back into the equation and I hit enter and it redoes everything for me. And now I can change some of the parameters again. Now it's 23 years, the same thing. The 6.5% is still in there, but it says compounded semi-annually, which means 2. So that means where I see 1s, I'm going to turn them to 2s. Then I'm going to hit enter, and then I'm going to go ahead and check my answer. I got the same exact answer as what's on my calculator. All right, that's the power of knowing, and I'm going to zoom out or zoom in again. All right, it wants us to go ahead and evaluate the same number structure. So all I got to do is come up here, hit enter, and it writes everything for me again. So then all I got to do is say, oh, it's quarterly. All I got to change my 2s to 4s. And then I have that, and I just hit enter, and there's my, I would write that into the next answer. Same exact information again, monthly. So I'm going to go ahead and punch that in for monthly. Means it's going to be 12 times a year. So go ahead and put in 12 for the for that. Second insert allows me to put in numbers, by the way. And then I'm going to change that to 23. Excuse me, I'm going to change that to 12. And then I get my answer. All right, my answer is agreeing to everything that I'm seeing here. And it says daily, there's 365 days in a year. So come up here, hit enter. Rather than putting all that junk in there again, I'm going to go ahead and change that to 365. 365. And then I have my answer. I love it. This is really working out really easy. Okay? Because I already have everything in there. All I'm doing is changing the how many times it's getting compounded. And the last one says continuously. Now that one, the formula is a little different. That one uses PERT. So now it's 27,000. And then I need to use, because it's PERT, it's P-E-R-T. All right, P-E-R-T. I know it's a little blurry for you, but you can read that. All right, so it's the principal, and then I have to use second ln to get E, and then the rate is 0.065. That's what, it's the same exact thing, information, and then I'm going to multiply that against 23 years. And then I check my answer on that one. All right, look at how the answer looks the same. Okay, knowing how to round, make sure you know how to round that. Okay. All right, now I've gone ahead and showed you how to use your graphing calculator as a significant piece to you. It really is important. Can't lower the brightness of this anymore. Anyway, okay, well that was a long process, but it was absolutely doable. I showed you how to use the calculator effectively. In a manner of speaking, they take PERT and I'll give you different values with this. So since it's all running cumulative, or it's continuous, excuse me, I'm taking this formula up here, and since I already ran it, and you can't read it, but I'm taking this equation right here, and I'm hitting enter, and I'm just changing the parameters. So it's all set up already. So it's 38,000, so 38, and it's already there, and it's 11.5%. So it's going to be 0.115. All right, and then it's for 16 years. So I have my answer in front of me. This is just a matter of plugging in the calculator and hitting enter. All right, I just put it in the calculator. So I would again come up, hit enter, change it to 20,000. So 20,000 for 14 years for 6.5. No, excuse me. I got to do 20,000, 11 years, and then 9 point, so 0.95. And then I'm going to put it for 11 years. And then I have my answer. All right, and that's the answer we're looking at. I'll just plug it in. So then it's 25, whoops, clear. I'm going to go ahead and come up here, hit enter. It's 25,000, so I'm going to change this to a 5. And it's 14 years. I can go ahead and put that in real quick, 4. And then for the percentage of 5.5, it's going to be 0.055. And then I have an answer, so I hit enter. Or I have all my information, and that's the answer that we're looking for. All right. If you can't see what I'm doing here, then you need to slow me down by pushing pause and then keep up with me. I hit again, up, up. Okay. Since I can go all the way up to the where it says 38 and hit that one, and then change that 8 to a 5 because it's 35,000. So I hit that. And then I go ahead and change it to 0.65 for the percentage, and then 20 years. I'm going to change that to 20 and then enter. And I get the same exact answer. All right, you saw how fast I did that. That was pretty quick. And even though there's a lot to it, I mean, there's a lot of parts to it, it's not that hard. Now, 39 and 40, last two couple questions we're going to do. It says, what is the population in Stewart in 2020? That would be the 16,629. That's the answer we would put here. Okay. Now, I went ahead and instructed you on the possibilities of using your formulas. And I'm going to kind of cheat a little bit and go back to my notes that I gave to you on this. All right. Now it says, in what year is the population of Stewart projected to reach 21,119? Now it says what year? That would be this formula right here. All right. Now all we do is put in the initial population of 16,629, put that here, and put in 21,119 for A, and then put in the K value of 0.002277 for K, and that will go ahead and give us our answer. So without writing a single thing down, because I know this formula, I knew this formula by heart, all right, I would go ahead and just drop it into my calculator. So I'm taking and doing second math, and then ln of, and then I'm hitting alpha, that again. I'm going to go ahead and get the initial or the projected value of 21,119 divided by the initial population of 16,629. And then I'm going to go ahead and close out my parentheses, come down to here for my K value, put in 0.002277. That's what I'm putting in the denominator. All right, and I'm double checking that everything looks the same, because that, transcription errors happen. And I'm going to hit enter. Now that says 104.97. It wants the nearest whole number, so it's going to be 105 years after 2020. So I'm going to go ahead and put, since it's 105 years, I'm going to put in 21. 25 is my year after 2020. So that's going to be the answer we're going to put is 2125. All right. Now, I will zoom in just in case you did not watch the other lesson. All right. That's all of what I put into the calculator. All right. And I know it's blurry for you. You couldn't see it and you were getting angry at me. But I did teach this to you, and I showed you how to make it really simple in using this formula. All right. And now why is the answer not 105? It's because it says, what is the year of the population? So it takes 105 years for that population growth to occur to that projected number. So we go ahead and add those years to the current year of 2020. All right. So that's me using my formulas that I gave to you that are so effective. Now the last one says we have this problem, right, where we have the equation that I've given you before, okay? I told you the formula was A equals A sub naught times E raised to the KT power. They're using, rather than A, they're using Y, okay? Now for this problem, we're going to use that formula, and it says first of all, we have the problem is in 2010, Sebastian had a population of 21,674. Then in 2020, it says that it's 25,538. Well, we need to use this equation to determine what the K value is. All right, the K value. So, matter of fact, I do believe strongly that the problems in this lesson were very reflective of what was given here as well. So what I'm going to do is show you, and I don't think I have it in there anymore, so I don't think it matters, but I have this done where we worked on it together, but it's actually up in here still, okay? And I punch it in, all right? And we have this problem that I did for you, okay? And it's reflective of what we're doing here. All right, that's the problem we're working on still. So I'm going to hit enter. All right, it's still 10 years. So we're looking at the value of Sebastian is 21,000 initial. All right, the initial is 21,000. So I'm going to change that to 21,674. Changing the value of the projected is 25,538. All right, and I did. Oh, that's because the initial I put them actually opposite. It's supposed to be the initials on the bottom. I'm sorry, I did that backwards. I knew what I was expecting, so I knew it was growth, and it came out to be negative. So it made me look at it, and I entered it wrong. So I went, I'm coming back. I mean, and putting it in right. It's not that big of a deal. I now get it to be right. Now you're probably thinking to yourself, well, now these are the same exact answer, except one's negative, one's positive. And yeah, kind of, you're right. That's a good assumption, but always put in right. So now, what does this mean is that when you write your problem down, okay, when you write your problem, you write it as now the initial value, or excuse me, the projected value is the Y, and then it's going to be the 21,674 with E raised to now that value of 0.01641, because it wants it to 4 significant digits. All right, rounded to the 4 significant digits. So that's why that answer is what it is. And then, of course, we have T. Okay, so that's the equation that we need. All right, that's the equation that we need. And so then that's what they're looking for here. Okay. All right, that's the same exact answer as I just given here. All right. So let me zoom in a little bit so you can see it maybe perhaps a little bigger. All right, that's probably easier on your eyes. Okay. Now you see that that answer is what I've given you. Now it says use the population growth model to predict the population of Sebastian in the year 2026. Right. Now 2026, that would be how many years after 2010, and of course that's 16 years later, right? So now that would be where you change t to 16. So you just drop in your calculator the value, and I'm going to just put it in there. So 21,674, and then second ln, and then 0.01641 times 16. And so we get this answer just by putting in the calculator. And that's the answer that we get right here. So it's 28,182. All right. And then determine the year when the model predicts the population of Sebastian will be 43,651. Round the solution to the nearest whole number. Now, when they talk about that and when we're talking about years, they're looking at this formula. So what I'm going to do is I'm going to drop the formula. I'm going to put that formula together with what I have. All right. I'm going to go ahead and grab it and plug it all in there in the calculator. So you do the same thing right now if you wish to follow, right? So we're aiming to please here. Let's go ahead and put that in there. All right, we're going to go ahead and put in the initial population is the 21,674. The projected value that they're looking for is 43,651. And then they're looking for the growth factor of that, which is 41. All right, I got it all in there. That's going to occur 43 years later. Okay, and it says in what year. So what we do is take 2010 and add 43, and then get the answer of 2053. All right, I'm trying to stop my hand from moving. Holy cow, I have like not the controller with two hands. All right, that's better. All right, try to give you a moment to look at it so you can copy, take a picture of it. If I've stopped moving all over the place, maybe you can see it better. All right, so that is the answer we're looking for, and that is the conclusion of this review. So I went over quite a few questions. I did make one mistake that I fixed. All right, and I'm glad to make mistakes, because then it makes me help you not make them, because I bring it to your attention that it happens to the best of us. So and that mistake happened, I believe, that was the mistake I had. I remember all my mistakes, by the way. I accidentally added the L or the 8 to the ln. How can you do that? I don't know why I did that. I just did. So I made one mistake. All right. So avoid that. All right. We went over quite a bit of questions, and I look forward to your success on your test. Now, remember, the test is open now, and it closes on the Sunday. So that's it closed on Sunday. All right, of the 31st, actually closed on the 31st. You now have the ability to get it done by this Sunday. I've covered all of your stuff, and you can get it done by this Sunday. That's great. All right, enough of that.